This conference will now be recorded.
So good afternoon, everyone. Am I audible? Am I audible?
Yes.
Hello. Okay. So before starting the layout demo, I'll just give the idea about. Hello.
Hello.
Oh, good.
Hello.
Yeah, I already joined, sir. Okay, sorry for little delay. Now it is fine. Anybody can tell, like, am I audible or okay? Yes.
Yes, sir, you are audible.
Okay. So generally, we have in VLSI industry, we have a two type of domain. One is backend and front end. So in backend and okay, let's first we'll take front end, another is back end. So in the VLSI industry, this is the two domain, but there is segregate. We have a digital domain, we have analog domain, standard cell, memory, IO. So this front end people for digital it is called RTL design engine, and for backend that is called PD, physical design engineer. And for verification, that is called PV, physical verification guy. For analog, we front end people call analog design. Here analog layout. Back end. Standard cell designer. Yes, standard cell layout. Similarly, memory designer, memory layout. IO designer, IO layout. So these are the domain. If you see some verification, RTL verification, so whatever coding they will write, that is called DV, digital verification. But for analog standard cell IO, so all will be done. If you all this combine, we call custom layout. Analog standard IO memory generally it is a separate domain, memory layout domain, custom layout domain. So whatever course we are going, there is a background course. So we have dependency, front end people are there, but generally back end people, if you industry, the number of opening will become more mostly in back end domain. Here opening will be less because requirement will be less. But DV people are little bit high because the coding will be sometime memory verification here in memory verification people. So that time requirement will be if you see designing analog design people ratio layout people will be so about 10 people, design people will be 5. So in that ratio will be work. So now you got idea. So we have dependent front end and back end. Except this some testing team DFT. So whatever the project will do, they design for stability. One domain will be there for testing purpose. There is a separate. So now come to what is the our work, then what is the syllabus. So in the layout people, what you will do generally. Suppose you want to build a house, you have given certain area. So you have given like 100 mic 100 square foot area, like 1000 square foot. You purchase a flat. This much area given, certain one must 2 BHK room, one is master bedroom, another is some study or guest room. Like this is given. So how you plan it the better way? Like you will just try to relate it. Suppose you are given certain area, how you are to use. So in the VLSI means you have a transistor, MOS. So if you see a example of a full chip layout, this is the diagram. These are the full chip layout. Okay, so how you arrange as per certain constraint. So similarly, when you making a house, so how properly? Okay, so first stepwise. So you have given like house related will try to exam relate it, then it will be easy to understand. So you have to make a house. So this is 40 curves, 40 you have utilized for your master bedroom. Some suppose one kitchen area it will take. Some people this will be not right. We'll do some other floor plan. They will arrange like this. Balcony will be other side. So this type of different type of floor plan will be there. So that at last it will be you have to proceed, like you have to some architect or interior designer, they will design this house. Similarly, you will be do in the layout. Two type of floor plan is there. Suppose you arrange a in the circuit, you have a, some analog block, you have some memory block. Generally IO will be in the periphery of the circuit. Suppose IO are there. Let's take an example, the application of a chip in the laptop or mobile phone. So there are some pins will be connected. So input and output pin, some test purpose pin will be there. So some analog signal will be there. So they have given certain area, this will be analog. Some will be digital, like PD people will utilize some memory will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will
Hello,
be
sir.
there.
You are not
Some
audible.
analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there.
This conference will
Some
now be
analog signal
recorded.
will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Some digital signal will be there. Some analog signal will be there. Hello.
Yes, yes. Now you're audible.
Okay. So I'm just revising a topic. Those who miss because sometimes network was not there. So we have just started. Analog layout is the backend support. So mostly where dependency is the analog design, memory design, and standard cell design people and IO design people. So this is the front end guy. So we are in backend. So in the backend, what course suppose we have given a analog layout people, what we will do, certain area is given, will the analog layout job, digital layout and memory layout job. Okay, and digital layout is like a PD only, physical design people, they will use through script. So they have some tickle language, all these things. So but whatever our job will do some manually job. Okay, so we don't need any coding, those are background from not digital also can work. So only the understanding of s- some circuit basic, how it is work, layout concept. So if you know, you can execute the analog layout or custom layout thing. So in this, so what is the syllabus we are going to cover, I'll come to this. So generally 6 month course. So 2 month will be basic training, 4 month will be advanced. So in the basic will be some KCL, KVL. So you might have BTech, you have studied some basic resistance calculation and some layout dependency effect. So antenna, oil proximity length, diffusion, shallow trench isolation. So these are the new concept, layout dependency effect, some CMOS fabrication and schematic layout. So layout, what we will do. So I just explaining like this is just a, I'll give some idea about in your hometown. Suppose you are building a house. What you are saying? Step one, you're planning. Okay, that planning is called floor plan. Okay, so floor plan is just you to like architect job people. They will arrange like 2 BHK room, uh, one room where balcony will be there, study room, where is the kitchen, like this, all this arrangement. Then the layout, that is called floor plan. When the final floor plan is called, that is called second step is called placement. That is a fix. You are not supposed to change and again. Once placement is done, like your house, you plan this in the paper only, architect will use paper, but you have to give plan in the execution. For execution, you building the house, you need a brick connection, cement, rod, all these things. So in the layout, that is called routing. Route means a connection. So once routing done, after what do you do? Brick all connection, whether it is strong or not. You have to follow certain rule. So in the layout, that is called DRC, design rule check. And after your home, you completion, you have to first floor, second floor, like that you have to complete. So that completion is called LVS. LVS means layout versus schematic. Like you have to compare with whatever the front end people, those people give you some schematic. Their input is schematic, your will be layout. So that will be compare LVS. So these are the flow will be there. Certain extra check will be there for plan placement, routing, DRC, and LVS. Okay. So thing how it will be executed. I'll just give the demo also. We are using Cadence, sometimes Synopsys also, to by which tool will be executed. And whatever layout diagram I saw this diagram, these are done by layout people. So in the when you are seeing a chip, mostly that is contribution by layout and PD people. But our area will be more. It depends upon the project requirement. Wherever PD people will do some area, or layout people. But finally, chip you will see by your work. So front end people will not see wherever their block is designed. What you place, you can see. So that is the beauty of this layout domain or PD also. But PD needs some script timing analysis that is different. Here timing analysis not required. But how to improve R and C parasitic. So that thing will be covered. So layout concept, stick diagram, crosstalk, matching, ESD, electrostatic discharge, shielding, design for manufacturability, DFM issue will be covered. Next is which are the project will cover level shifter, current mirrors, mid-trigger, operation amplifier, LDO, PLL. So LDO, if you see, you need a high power management circuit. LDO application will be there. Band gap, your mobile phone, your constant voltage you need. You have to operate in a different temperature, but voltage should not vary. Like if you go in a very low temperature region or high temperature region, so output voltage should not change. So that is the application of band gap. PLL, if you are seeing in the high frequency in terms of gigahertz frequency, PLL will generate serializer, this pen drive, some memory data will be transferred with high speed. Then serializer SerDes will be required. ADC, any signal convert to analog to digital or digital to analog, ADC application. So everywhere you will see MOSFET, some BJT diode will be utilized in the chip. But MOSFET is a 90% constant. Means it will be considered in the full chip, whatever diagram you are saying, MOSFET will be 90% area will be covered. So CMOS means complementary metal oxide semiconductor. There PMOS will be there. It is combination of both PMOS and NMOS. Some device physics will be covered like PN junction, how it is working, forward bias region, reverse bias region. This is the fabrication CMOS, how it will be formed. Some stick diagram. This is the CMOS, PMOS, and NMOS. This is the stick diagram like this. And layout, how will you implement? This is the schematic flow. This is the layout. As I initially told, we have to verify DRC, design rule check, and some LVS. We have to compare schematic and layout. Layout netlist and schematic netlist. Netlist means it will be stored in a certain file. And how tool background it is working. That example I will show also. It's just a demo of a voltage control accelerator. Layout definition effect. So some new concept only related to layout. Latch up antenna, electrostatic discharge, electromigration, oil proximity effect, length of diffusion, shallow trench IR drop, ground bounce, DFM. So these are the layout you might not have studied before. And some second order effect. Some FinFET basic will be this is advanced node. So we have a 16 nanometer tool also there. 14 nanometer will be generally, but we'll give you some example of 16 nanometer tool also. So we have a FinFET option here. So these are the project list. So this PPT you can take from our institute. So now I'll show you some tool demo how it is working or layout. Before that, anybody having any doubt?
Sir, I have a question.
Yeah.
I just want to ask for what technology node we are going to work on, and at the end, how many projects we will complete.
So technology node you will be cover here 28 nanometer, 40 nanometer, 90 nanometer, and 16 nanometer. These are the four technology option available in our tool. But this is the Synopsys 28, 14, 19, and 16 nanometer. But most 70% course will be given by 14 nanometer demo, because directly we can, this is a FinFET, some understanding directly we cannot give, as you need to understand the planar technology. So these are the four technology you will get.
Okay, so I mean, sir, it will be in like cadence what you saw or like Synopsys custom compiler.
It will be both cadence and synopsis. So mostly you will be go to cadence only. Because cadence is the advanced node. So I'll just show you now the cadence technology demo here.
Okay, thank you.
Sir, analog design is like LDOs and DAC ICs or one of the chip like AMD or Qualcomm chip inside portion.
So analog design and analog layout is different. So you want to know about what is analog design.
Analog layout.
Analog layout application you're telling, where we are utilizing.
Yeah,
So
like it's ICs or chips kind.
now IC chips is a different thing. IC is an integrated circuit. Okay.
Mm.
So layout is whatever the circuit. So like a front people, they will do analog IC design. Okay. So they will do the
Okay.
schematic design. So if I show the example, let me connect the tool first. So what is the schematic means? You have a, let me connect once. You can see very clearly. Okay. So tool line. Suppose whatever we are designing, suppose a NAND gate. So NAND gate, truth table like A, B, 0, 0. It will be 1, 1, 0. So for this, everywhere you're using MOS, either PMOS or NMOS. We need to design a NAND gate. So A dot B whole bar. So dot means series. So make it A B series of the NMOS. I just tell you why it is series. So this work will be done by analog design people, or that is called IC design. But whenever the next part is called, we have to implement. Okay, how this is correct or not? They will cross check like a equal to 0. 0 means this taking aim. This is 0 because digital either 0 or 1. 0 means PMOS will be on, NMOS will be off. NMOS will be on by 1. So this will be off, this will be on. So now a supply is ready here VSS. VSS mean ground, here supply. Let assume digital high 1 only. So both it is on, so output you will take 1. This is satisfying. So if it is in this circuit, so this designing work will be done by the like analog design, memory design. So these are front end people. So this will not be the layout. When a chip it is meant is small size, its layout when you will do. So layout it is tool it is I'll just need to ask tool access they have not given. Okay, then best I'll just explain how do a start a layout. You have a circuit is given. This is not get given. So CMOS, PMOS means we have a three terminal. One will be source, drain, gate, another is bulk. Bulk is body or so total four terminal. So in the layout, you will also see like gate, source, and drain terminal. Bulk will be see it will be surrounded. Bulk mean inside. Actually, if you do a PMOS cross-sectional view, how it will be looks like. Inside a annual. So annual means n type of a semiconductor. Here P plus will be there. P doping concentration high. So this thing will be basic class they will cover. So one will be gate, source, drain, ball connected is n plus. This is the internal structure. So total four terminal. So inside annual piece mass. Annual similarly piece of inside annual n plus n plus. The plus means it's a you might have studied p type of semiconductor, two type of semiconductor, p type n type. The plus means doping concentration high because current will be flow. This is the channel. Whenever you are seeing the channel is like 14 nanometer, 16 nanometer, 5 nanometer, 7 nanometer. These are the channel length. So here the channel will as per your gate voltage. Suppose gate voltage here is a we are telling PMOS is on at 0. 0 means a negative voltage if you apply. So negative if you apply, positive it will be attract. in between some dielectric will be there. They are separated. So you apply like here, this is like a capacitor. You apply positive or magnet. Now magnet will be attract opposite pole. So here negative will be deposit. So here similarly, when you apply negative voltage, positive will be deposit. That positive it will create a channel. From source to drain, current will be start to flow as per your potential difference. So 0 PMOS will be on. Okay, so this is the how cross sectional view. So now if you see in the layout, we have a, this is first we have to do a stick diagram. This is just I'm telling. Tool demo we have a separate lecture. But now why it is not working? I can show the cadence demo. Now it is. Some issue with the server, so I'm not able to log in. But we have a cadence tool only. Okay, I can show the diagram then. So whatever I come to your question. So the layout application means, so front end people design specification, they will design the schematic like IC order. Next is we have to implement this is the layout connection, because chip current will flow, power function, different function like in AI chips we are using now in NVIDIA they are using sub data center automatic. Uh, Suppose you are sending mail, some or Microsoft, all this it will be controlled by a data center chip. So the AI application is there in mobile phone. Snapdragon you are using, Qualcomm Snapdragon or MediaTek you are using. So these are the chips application. Even your laptop also like Intel, AMD Ryzen series, and SanDisk some memory chips you are seeing, SanDisk memory, Micron. Okay, so many company are there in India also. Many product company and service company are there. Okay, so there is a difference between service and product. You have idea. Once in the openings it will take. I'll just write in between tool coming. So there is a different character, a service and product company. And some product company also divided into. So service company, if you see SCL, previously it was known as Sankal. So there are many company. I don't want to list it now. Like Intel, some tool-based company, Tool, Synopsys, Cadence, and Mentor Graphics. So these are tool-based company. And product company, you have TI, Texas Instrument. They have power management is a big. You have Onsemi, Micron, Sendix, Qualcomm. These are the product company. But service company are there. They will be some client. They will hire and train them, and you will act as a contractor there to a product company. But you are the full-time employee in service company, but you will be act as a contractor in the product company. Product company, some portion like you, they need a 1 year project. Through service company people, they will complete that project. Then they can release 1 year, 2 year like that. Some contract will be there. Understand or any doubt? So some people having doubt. Service company will pay around, range will be 4 to 7, but product company will pay 16 to 23 range. So last times one uh, Micron was and on semi like 19 lakh their base they are giving some two joining bonus, like 21 also they are paying for fresher entry. Micron also they are giving around 19 lakh in layout domain. I'm telling analog layout domain or custom layout domain. I just check they are telling us issue with the internet, so I'm not able to show tool demo. We have a recording. Okay, still anybody having doubt, let me know.
Sir, I have a question. Sir, I am 2019 pass out and have some experience in layouts. I mean standard cell layouts. So,
Okay,
am I be good for both? I mean, for the placement support, the are we going for the service of the product-based company, or both are coming for the placements?
but you are having experience or
Yes, I am actually having experience in standard cell layout. I want
that
to
I
learn
understood.
analog layout.
Uh, Analog layout you want to learn, but you can try outside. Not a issue for outside. You also will be experienced, but institute they'll come fresher people. Outside you can easily in
Okay,
LinkedIn through you want to change, but your profile will be analog layout. You can show like our project PLL, LDO, serialized shortest projects will be there. So you can add in the resume this profile you have done. Whatever the interview support also will give you, because mostly my domain will be I have having 9 year experience in analog layout. Okay, so my specialty will be in analog layout mostly, but I work in IO standards less I work. Okay, so
yes,
my
sir. I want to learn analogs.
so analog you should not worry, you can learn and you can add resume. Now outside like how you applying like 3 4 year experience, you can show once analog layout you are.
Uh, okay, okay. Thank you, sir.
And anybody else having less than, suppose now 2026 pass out, some people having less year experience pass out also in layout domain also they will take, say service company, they want some people having 2 3 year back people also they will hire, and they will train them and put a experience to product company. That is also happening in the industry. So we should not worry about like my there is a gap, so I will not get the company. Yeah, anybody else? Or if anybody is interested for tool demo, maybe we'll connect again, or we have a recorded session is there. You can go through once. So these are the PPT also will share whichever topic we are going to cover, and some shortcut. We will just give you also some basic of analog design, like schematic will not give directly how it is functionally operating. Suppose any op-amp will be there, operation amplifier, that functionality also will be covered. Or any PLL also. PLL we are using. It is also a big project. We have phase detector. We have a charge pump. We have LPF, low pass filter, VCO, voltage control accelerator. We have frequency divider. So we will be understanding how it is function. It is not directly will give you the schematic and start the layout. So understanding of the will cover you, so that you will do a better layout engineer. And R and C calculator means how will be improve resistance and parasitic. Okay, let's take an example. Suppose I'll just give you example. Your inverter. This is just a inverter CMOS. CMOS is just a inverter only. So when a digital signal is coming inside, like 0 or 1, when 0 is there, this will be on. PMOS will be on. This is like a switches. PMOS will be on, switch will be closed. So it will be output. This is output will be VDD, means 1. If this is on, VSS will be, so output will be 0. This will be continuously charging, discharging, charging, discharging, like that. If charging discharging means if there is a capacitor connected here. So if it is 0, this PMOS will be on, so VDD will come. This capacitor will become charged. If this is on, whatever charge amount, it will be discharged. So this is charging, discharge will be continuously. Okay, so now if you do a layout mistake, suppose you did layout means you have to connect routing. Routing means some metal will be there. So if this length will be little high, you did for output connection. For this, you use a, let's take a 2 micrometer, but out output to VSS you did only 1 micrometer. So for this charging will be, so length R equal to rho L by A. So length increase means resistance will be increased. So for charging, you are taking your mobile phone. Take example. You by mistake layout people are doing huge mistake here. So mobile phone charging you take 1 hour. Like if you see iPhone, like Samsung or some old mobile will be Xiaomi. It will take 2 hour to so whatever chip they are utilizing in that, so there it is not that much faster. So charging time it will take. Discharging time will be very slow. Means it should be discharged very long period of time, because if mobile phone charging 100% done, if it is discharged long period, so that is how layout people can change also. R and C timing analysis also control. Just a taking example. If you bad layout engineer also can destroy the work functional working also. So need to understand means how it is working. So that concept also will be covered here. So nowadays FinFET also like it is the faster chip. So within 30 minutes it will be charge your mobile phone. So there if you see in the Qualcomm Snapdragon 2 nanometer, 3 nanometer, 2 nanometer still now the R&D search, but 5.7 already proven, already come to market. If you see Snapdragon, okay, so flagship they have started using 5G. I think now recently Samsung S26 Ultra there is a Samsung S21 already they have used OnePlus 9 Pro. Okay, so tool is not working. I about to show this demo, but unfortunately the Excel is not working. So this is anybody having doubt, let me connect, otherwise you can close. We have a
Sir, I have
record session. Yeah,
sir, we will like when we will get the tool access, what are the how many projects we are going to do?
project will be 16 to 17 project will do. So these are the list here. 3, 6, 9, 12, 16 project will be some real time, that is the extra. The 16 to 17 project will do. Once you join they will give the access. From day one
Okay,
onward you will get. So it is not like after standards had completed like basic you will be get. So day one onwards they will give the access. So both we will get synopsis and cadence tool access.
okay, sir. Okay, thank you.
And there will be another guy who will be joined for basic course. Initially 2 month some basic, like you will be not only cover layout domain, some PD, some all topic also. You have initially they will cover like standard cell, all this basic thing also they will cover. So after that 4 month advanced course I will be covering. This is the plan. But in the
Okay.
2 month initial also that guy means another instructor, so he will help initially.
So sir, like theory and practical both are taken by you. Like,
The basic I will not take, advanced I will take.
oh, okay, sir.
So that 4 month session I will be covering.
Okay, sir. Understood.
Okay.
Thank you.
And in between also some extra thing, Linux tickle programming, so this will be covered by some other different trainer, like those who are specialist. So this is like a multiple thing you will be covered. But and layout related some 2 month basic will be covered one guy. Initially he will be continue some lab session all this thing, but I will be 4 month both lab and theory also I'll cover. That is the.
Okay, sir.
So thank you so much. If anybody interested you can connect with our institute. And any demo thing for tool related I already given 2 3 demo for only tool recorded. So those who want to know you can attend that demo. It is already recorded.
Hi, sir. I have a question. Hello.
Yeah.
So, what is the job assistance in after completion of this course?
After completion, there are some company tie-up is there, so that company will come to our institute.
Okay.
But outside, so you will be get better understanding from Srinivas sir. He is the head of this institute. So
Okay.
you will better clarity from there. So I'm just a trainer. I'll help you whatever the outside opening. I'll keep on posting in the group, and institute will bring some company. So he will guide you. Means how many some previous company having some tie-up. So company will visit to our institute and they will take. So that is also tie-up is there. It is better you can talk with Srinivas sir.
So, in
He's
Hyderabad
the
location or in a different Bangalore location, he is located in.
he's located in Bangalore location. That is the main part of Hyderabad. Just a recently branch is open.
Okay. Okay. So, may I know your name?
Suresh.
Suresh. Okay. Okay, sir. Thank you.